This evening for me. Zoom is telling me that there's a recording in progress. Yeah, so welcome everybody. My name is Bas Land. I will be hoping to share some of my knowledge on using Python modules in Microsoft Fabric in order to don't repeat yourself, to create a little bit more dry solutions. So to say, usually that's not a good thing. I think when building software or data platforms or whatever, it is actually a very good thing that we are implementing with our customers in practice every day. And I'd like to share that knowledge and experience with you. So let's dive into the session for today. Before we start looking at the actual don't repeat yourself patterns, I would like to lightly touch some of the core concepts of Fabric Compute in order to give some boundaries of what we're actually talking about when we speak about PySpark, about notebooks, about Python modules, and so on. We will then introduce the problem of writing repetitive code, right? And then we will, of course, present a solution. It's not my solution. This is something that is created many, many, many years ago by I think people that are a lot smarter than myself, actually. But we can use that information, that knowledge, and that theory inside of Microsoft Fabric by using Python modules. We will also do a live demo, and the demo will not be a full-fledged data platform that we're actually demoing. It will be a lightweight demo that we can run in a few minutes in order to give you a hands-on overview of what we actually can do using Microsoft Fabric. And so that you guys know where to start if you go into work tomorrow. You actually know how to start setting up Python projects, creating modules and importing and reusing those modules within your Fabric environments. At the end of the session, we will have time for some questions and answers. If there's any questions that are about things that I'm talking about the slides on my screen or during the demo, please write in the chat. And then I think, Emily, you can monitor the chat in order to do ad hoc questioning. If it's not about something very specific on the screen, we will have time after the demo.
Absolutely, will do. I'm looking forward.
All right, then let's dive into some of the core concepts of Fabric Compute. I have put two images on the screen here. On the left side of the screen, the blue image that you see are some of the compute options that we have within Microsoft Fabric. The bottom layer is the one lake layer where all your data is stored within Fabric. The layer on top, saying data factory and data engineering and so on, are the different workloads within Fabric that you can utilize as a data engineer or data scientist or an analyst or whatever your role might be. You can work with all these different workloads that are interacting with the data in your one lake one way or another. It can be reading files from your lakehouse, or it can be querying tables on a data warehouse, or it can be running streaming analytics using Data Activator. That should be renamed to Activator, by the way, right now, I think. They dropped the data through a CustoDB database. And everything that's happening in between, the reading and the writing and the transforming of the data on that one lake is what we call compute. And then Microsoft put that compute layer in the cloud as a serverless solution where we can run different technologies in order to compute our data that is sitting in one lake, all right? Without going into all of the details of what the compute actually does, there are a few different engines that can provide compute power in your Fabric environments. One of them is your Spark cluster. Another one is TSQL, where you can write transact SQL against your lake houses and warehouses in order to analyze data, write data, and so on. And then on the streaming analytics side, we have compute in the form of KQL. Today, we'll be looking at the Spark compute engine and how that will interact with Spark, SQL, and Python in order to make our lives as data engineers or data architects a little bit easier by reusing some of those compute components. That's basically what we're trying to do today. Then on the right side of the screen, you see the white background image, which shows you not the Fabric environment with all the different components that are in there, but it will show you a medallion architecture of how you could potentially set up, this is just a suggestion, how you could set up a data platform using Microsoft Fabric. This could just as well be Snowflake or Databricks or anything else. As a Microsoft consultant, I should not say that maybe, but bear with me, this could be any other technology than Fabric, right? This is just a methodology in order to set up a data platform. And what you will see here is that from left to right, you will have a lot of data in your applications, your files, your lists, your external applications, your sensors and streaming data. And you want to have that data going into Power BI in this example. Maybe it will go into a machine learning platform, into something else. And in order to do so, we need to transform the data. We need to program against an API in order to take data into our lakehouse. We need to write queries or things in order to transform the data into actionable insights, into dimensions and facts in our data warehouse. And then we can load it into Power BI. And all of those actions that we do, the loading of the data, the transforming of the data, that is consuming compute. And that compute power can be delivered through Spark or TSQL, where today we'll be looking at Spark and how we can use notebooks and then Python modules in order to make the code in our notebooks a little bit smaller, and by reusing patterns instead of writing them for every table that you extract or every upsert that you run, you will be then reusing the existing code that you've created. All right, let's look at what Python inside of Fabric can do. And let's start off by saying Python and Spark will work together quite nicely. Maybe that's an understatement. For the past 12 years, I think I've been working as a traditional SQL data engineer. Started out with SQL Server and then did Azure SQL. So I was a bit reluctant to start using Python and PySpark in Fabric. But when I started using it, I quickly saw that the possibilities are really nice. It really brings a lot of functionality and a lot of ease of use for me as a developer or engineer to my daily work. And especially because in PySpark you can also run SQL. So for some of your tasks you might do SQL. For other tasks you might run Python. Within Python you can create these modules that you can reuse. It's easier than in SQL. So that will really broaden your toolkit and help you become a better data engineer, I think. Some of the benefits of using Python for data engineering tasks is that there are extensive libraries for very common tasks. For example, for computing statistics or for doing data engineering workloads, you don't have to reinvent the wheel yourself. There's lots of smart people that have already created all kinds of libraries containing code that you can just import into your Fabric environment and start using. So that's actually quite good. You could think about libraries such as pandas, where you can work with data frames and do data transformations without actually creating all of those tasks yourselves. Then with Python, I think as well with SQL, but also with Python, there is a massive community support. It is, I think, by far the most popular programming language at the moment. People coming out of universities are all being taught Python, and basically the whole world seems to be moving in the direction of Python for data engineering anyways. Besides SQL and more of the traditional languages and technologies, I think Python is the most popular there. So there's a lot of, as I said, there's a lot of knowledge in the community. There's a lot of support. You can easily Google for things. You can Stack Overflow them. You can chat GPT it, and Python will just be one of the languages that there is a lot of help available for. It also gives you a lot of flexibility in data engineering tasks, and that is one of the things we will be looking at today. Especially by reusing code that we could not as easily do in SQL in the past, we can do in Python today. And now, mind you, I'm not a Python developer. I'm not a software guy. I'm a data guy, so I will look at Python from that perspective. For people that have not seen Python before, I don't know your backgrounds. Maybe you've been programmers for all your professional lives. Then maybe this will be a bit too easy. But for people that have never seen a bit of Python code in the past, this could be your very first Python program that you run. It will be a hello world, but it will be a hello world program that also computes two numbers. It will add two numbers, and it will insert that variable total into a string that they can print, where you can easily see that you can manipulate numbers into variables. You can add those. You can put strings and numbers together, and you can print a message, and it will show you hello world. The total is 3. Now, this is a very easy example, of course. But this is an example that I actually took inside a Microsoft Fabric PySpark notebook. So this is Fabric that we're looking at, where we can start working with Python to do all kinds of things. Of course, we can also work with data. That is what we're doing. That is why we're here today. And what you're seeing right here is an example on how to create a Spark data frame within your Spark environment. A data frame can be thought of as a temporary table that is living in memory in your session. Maybe if you've ever written a pound symbol in SQL to do a temporary table. I'm not sure if it's exactly the same. I think of it functionally as the same as a temporary table in SQL to create Spark data frames in my PySpark notebooks. And now what you're seeing here is that we declare a list of columns, ID, name, and age. We declare a list of tuples with data, where you see 3 rows of data. And then we create that data frame using the data object and the columns object. And we can then show the contents of our data frame by manipulating or by running the method show on our data frame object. We will see that the table at the bottom of the screen is printed out nicely. Now, of course, creating data frames like this is not something we would usually do. Usually you would create a data frame by reading in data from a Parquet file or a CSV file, or from running a query to a database and then populating your data frame with the result set of that query. But this is just an example that is very easy to demo, where we can actually show how a data frame could be behaving. And of course, you can do more complicated things using Python. In this case, this is an example that I will not dive into all of the details, but this is an example of how you can run a parallelized notebooks using an orchestrator and a worker notebook, where you then can run, I don't know, many different API calls from the same notebook at the same time. Instead of looping through all of them one by one, you can loop through all of them one by one, build up an expression that you will then execute, and you can then execute multiple tasks in parallel, which makes your tasks faster, cheaper, easier to manage, and so on. All right. The problem that we will run into if you start giving your engineers or your developers a new toolkit is that they will start writing code, they will start solving problems. That's all very good, but they will be writing repetitive code, right? Because every transformation that you do, you need to then load into a target table, or every API that you need to extract, or every API endpoint that you need to extract, you will start writing code in order to connect to that API and do authentication and do pagination and so on. Okay. It's not a good practice to have all of that code duplicated across your processes or across the different tables that you're loading or the different source systems that you're loading, because manual changes will be leading to errors. There's difficulty in scaling a solution like that. And also very importantly, there is an impact on the productivity and the happiness of your developers. All right. I know a lot of developers. I know no one of them is very happy to do the same thing 100 times, because he created 100 different tables with API calls, and you need to change one parameter in these API calls. He needs to do that 100 times, and he would be happy about what he did that day. That doesn't exist, right? So they will feel overloaded, they will burn out, they will start looking for other jobs. That's all bad stuff, all right? A real world scenario, maybe to link the theoretical concepts to a practical example, would be extending a dimension table that we already have in our data warehouse. All right. We need to extract a couple of new tables. So we're creating extract scripts against our database or source database or source API. We then create scripts for a silver layer or the persistent staging area, depending on what type of terminology you use there. And then we start adding the data that we now extracted out of our source into the data lake. We start now adding that data to the dimension table. We will need to add a join to our mapping query. We will be putting new fields into the mapping. So far, so good. But then we need to put the fields in the insert statement, in the upsert statement, the update statement of the merge, in the unknown number of the dimension, etc., etc. So you will see that we are repeating a lot of the work that we're doing. We're adding new tables. We already did that. Why will we be doing that again? We are adding scripts for our silver layer. We already did that. We're now doing it again. And then we start adding fields to our dimension. We put the fields in the select statement, in the insert statement, in the update statement, in the unknown member statement, and so on, which is a lot of work, where you can make manual errors quite easily. This repetition comes at a cost. You might think, okay, with a small data platform, with one fact table, 3 dimensions, one Power BI report, what gives? It doesn't matter. All right, I agree with you. It doesn't matter. You should not be doing best practice patterns just because. You should be doing them because they will give you something. Well, they give you something, a lower cost of operating your data platform. Because if your data platform will grow larger, you start incorporating more data, bringing the data to more dashboards, to more end users, the time you spend on writing and debugging your repetitive code will increase exponentially. All right. Because in every layer you will include duplication, there will not be it will not make your life any easier. There will be a massively increased risk of inconsistencies and bugs. Every time you start writing the same code, I mean, if you do it twice, that's fine. You can oversee it. You can make a change. You can fix a bug into the sites. But I've been building data warehouses my entire career. I've seen data warehouses with hundreds of tables, reading out of dozens of source systems. Inconsistencies and bugs are a big problem there. If you start running into all these repetitive patterns and you need to change one thing, you need to change it many hundreds of times, where it's easy to forget, and boom, you have another bug in your system. In one of the examples, in one of my earlier projects, we wrote release notes to end users saying, okay, this new functionality has been added to the data platform and to your reporting and so on. We always wrote, we fixed these bugs, we added these features, and probably we added another few bugs because it's so large you cannot oversee it without doing some smarter things. Right? There's also difficulty in maintaining and extending your code base, meaning that every piece of code that you write, you need to track, you need to usually have a pull request system, you have your version control, etc. Your code base will explode if you do a lot of manual coding. If there's a lot of repetition, your code base will simply grow out of bounds, and it will be very difficult to maintain and track that. So don't repeat yourself. You can remember this by the acronym DRY. I think there's another acronym as well. We will not be using that. It's called DIE. Duplication is evil. You can also remember it by that. We prefer the slightly more friendly one that says DRY instead of DIE. But anyway, this pattern is aimed at reducing repetition. It's as simple as that, right? We want to do things only once. That's it. If you forget everything I just said, and you can only remember one thing, remember this, we will be reducing repetition by implementing this principle. It is important in software development, and it has been for years. This is not something new, right? This is also not something that I came up with. This is just something that I, as a, I don't know, maybe a mediocre to slightly smart data engineer from the Netherlands has been using in my projects, and I like it. So let's learn from our software development colleagues as data engineers and start using the smart things that already exist in our world. It enhances our code maintainability, as we just discussed before. Less code means easier maintainability, less bugs, and so on. And it facilitates scalability. You can imagine that if everything is nicely put into reusable patterns, adding a new table to your data platform is as simple as writing one line in a configuration file or a configuration database. And that's it, right? You don't need to program anything in order to do so. So your scalability goes up. It's easy to scale from one table to 100 tables to 10,000 tables if you want. I put this quote here. I could read it for you. You can also read it. This is a quote coming, I think, from the Wikipedia page of the Don't Repeat Yourself principle. But what it's saying is that everything that you do should be defined in a single, unambiguous, and authoritative place. where single means that everything should be configured just once. For example, connection strings, file paths, and so on. If I see a solution where connection strings are duplicated, or I find the same connection string twice, that is an indication that the dry principle has not been followed. All right. So we will have a configuration database or a configuration file in which we put these things. We will have a configuration function or method in Python that we can call from all kinds of different places in our solution in order to find connection strings, file paths, security tokens, API keys, and so on should be put in key vault, but only once in that single key vault. And then we have functions to interact with that key vault. All right. Unambiguous means that everything should be clearly named and documented. This is something that we tend to forget when implementing the dry principle. Also, myself, I think I'm quite pragmatic. I try to fix the problem, make the solution workable, and then I'm done. According to the theory, you're not done. You're only done when you've documented everything and clearly named all your variables and your scripts and so on. And within Python, you have a nice function to put doc strings into your functions and methods that will explain what the function is doing, what input it expects, what output you can expect, and that will make your code more unambiguous or less ambiguous by clearly explaining what the code is doing and why. And then lastly, everything should be authoritative, meaning that there is a single source of truth for things like data models and objects. There should be just one process or one notebook, if we're speaking about Fabric, one notebook to generate your silver layer tables. Because the only thing that changes is the schema of your silver layer table and maybe the key and so on and the name. You can put it in configuration. There should only be one process that is actually altering those tables. If there's another process, and I need to change something to the definitions, I need to do it at two places, it's easy to forget again, right? So we should have a single source of truth, not thinking about the single source of truth of the data within our organization is our data platform, but also within that data platform, everything should be coming from a single source. All right. That was a lot of theory, a lot of big words. Let's start looking at how we can use Python modules to create reusable patterns. When you start creating your Python module for your data project, usually I don't start from scratch. We do have a framework in our company that we use and reuse, so that's actually quite helpful. When you don't have a framework like that, or you're starting out just from the beginning, you have a working data platform that you start implementing the dry principle in. You should begin by finding and using common functions and procedures. So think about connectivity to your data sources, to the loading and storing patterns, to the update, insert, delete scenarios that you might have when processing your data. Start looking at those kinds of functions, pieces of code that you can maybe abstract out of your notebooks, your pipelines, your queries, and start putting into a custom module. And what you will quickly find is that even within that module, you start reusing stuff. So you will be putting in a utils module that you then can call from your other modules and so on. There's layers to this, but start by finding these common functions that you have in your platform. You can then be sharing those modules that you create across different projects. And this is actually very nice. I've seen people writing Python code or PySpark inside a notebook and then attaching that code as, not sure what the name is, I forgot, but you can attach it as a piece of code to your notebooks, but then you start using it across your different projects. And then you have to repeat and duplicate that code again. So using Python modules, I think, is the only way to actually abstract out your data engineering codes and truly going into a reusable scenario. This will, of course, save you time, reduce errors, and simplifies updates, which is the opposite of the risks that we just discussed when repeating yourself. So why do we use these custom modules? The reusability is write once and use everywhere. That's actually quite brilliant. So in every notebook, in every pipeline, You will just call a function, and the function will do something depending on the parameters that you give it. I work as a consultant, so I have multiple clients that I help. Within a client project, I don't have to think about how does the upsert functionality work here, or how do we call APIs in this project. We do it with this framework, right? So it is also very consistent and predictable, and that's something I like. I don't have to think about how things will work. I know how things work because they work the same everywhere that I look. And it's very efficient. I can just deploy my data processing framework to a new customer or to a new project, and I don't have to spend time on writing and debugging and deploying and all of those processes in order to just set up the base layer of a data platform. We can just publish the module and we're good to go, basically. Also, it makes it easier for teams to work together. In the past, I ran into issues where a colleague did some work with a customer, I did some work with another customer, colleague goes on holiday, his customer calls, hey, can you change this small thing in our data warehouse? Sure, we can. And then you start looking into what is actually being created, and it's not necessarily wrong, but it might be in another person's handwriting, which is not the solution that I would have taken maybe. His solution is no better or worse than my solution, but it's a different solution. So you are spending a lot of time on unraveling what is going on, why people created things the way that they created things. So by abstracting out all of that work into a common module, a common way of working, we don't have that developer's handwriting as much in our solutions, making it easier for teams to work together, making it easier to onboard new colleagues, to teach them how to, if new people join out of university, it's easier to teach them how the platform actually works. And when they grow more senior, they can dive deeper into the modules themselves. But from the get-go, they can already start applying them without actually truly understanding the platform and all the complexities. So collaboration is a big thing if your data platform is growing. And then, of course, there is this growth that you can go through as a data professional or as a data team, where you might start with manual coding, lots of repetitive scripts. You can then start putting your functions in notebooks or in stored procedures, but today we're looking at notebooks. And then thirdly, the more mature step will be building and importing your custom modules. So that's what we will be looking at today.
Do we have one moment for a question?
Of course.
I have a very good question here from Emmanuel, who asks, what kind of processes do you recommend for version control of Python notebooks and environments? And
That is
GitHub integration with Fabric, is it enough or do you have to try some alternatives?
This is an excellent question. In our company, we use Azure DevOps as the version control platform. You can use GitHub as well. I don't think one or the other is better or worse. We like DevOps because it integrates with all the other Microsoft Azure stuff pretty nicely. One of the issues we're running into, and I don't know if GitHub solves that issue, to be honest. Maybe it does, maybe it doesn't. One of the issues we're running into right now is that we cannot do cross-tenant version control. So ideally, I would have all of the client's code in my repositories and then deploy that code into the customer's tenant. All right. In the past, we did that using Azure DevOps, using Azure SQL. We could have all of the code in our centralized Azure DevOps environment, and then pushing to the customer side. We cannot do that today with Microsoft Fabric. So what we now do is we have a central repository in our tenants using Azure DevOps Git to create the Python modules and to create the distribution for those modules. We'll be looking at how that works later in the demo, but we will be creating wheel files on our own environment. We will publish those wheel files using a build pipeline to a build artifact, and then from the client side we can grab that artifact and update the customer side to a new version. All right, so GitHub will work for that just fine. How the interaction with GitHub and Fabric is, I don't know because I've never used that. Does that answer the question or?
It did for me, and I see a thank you here, so I think so. Thank you so much for that answer. It
All right.
was a good note with the artifacts on the tenants. Thank you.
Yeah, I will not be showing the artifact creation and the build pipelines today, but I will be showing how you can manually create that build output using Visual Studio Code. In practice, you would put it inside of a version control system, of course. Yeah. Okay, then let's look at some of the some examples of the three stages that we see at the screen right now. So we go from manual on the left side to fully modular on the right side, with functions inside your notebooks in between as an intermediary step. But let's look at some examples for all three of these, so that we can actually place some of the concepts that we've discussed into code that we can see on the screen and all can understand. So I've written some code that is very easy. All right. So what we're seeing, this is not an actual example of a Fabric notebook. This is just some code that's been written and copied through in order to make a point. All right. So keep that in mind. We start a notebook at the top of the screen. We're importing some libraries, the PySpark.sql stuff that we might be using. We initialize a Spark session inside of Fabric. You actually don't need to do that. You already have a Spark session in your Fabric notebook when you run the notebook. So that's actually quite nice. You can omit that line in practice. And then we start loading in three different CSV files, one called sales, one called marketing, one called HR. And we will do some very simple data transformations on those data frames. So we load CSV file into a data frame, start manipulating the data in that data frame. All right, sounds easy. And it is easy. It looks easy on the screen as well. But we do see some repetition already. We're loading in CSV files, and we do that by utilizing the spark.read.csv method, which is actually a quite easy to understand method that we're calling. However, we do the same thing 3 times. All right. Now, let's say the data that we have changes and we don't need to put in first schema to true. We can omit it, or we should set it to false. I don't know. Now we need to change that 3 times. There's a problem. We also see that we're adding a column called date. Or actually we're casting a column date to a certain date format. This is a US date format, and we're changing that column. But we do that for all three of these data frames. In all three of the files, apparently there's a date column that we need to cast to another format. So there's repetition in there. There's more of this repetition in here. We see that there's some filtering going on, and there's I think there's renaming from revenue to amount and from cost to amount and so on. So there is repetition involved in this particular program that we wrote. What we could do is, in our intermediate step, is start creating functions. A function is something you will define. And I'm still not sure that this is where my SQL background goes to kill. I'm still never truly sure whenever I should call something a function or a method, but let's call it functions for now. It's probably wrong though, but let's call it functions. We will start create functions within our notebook. So it's not truly reusable, because in another notebook, I need to do it again. But at least within this notebook, I don't need to reuse all of my logic. For example, I created, using the def keyword, a read CSV file function, where I ask for a file path as an argument, and I will return the output of spark.read.csv, which returns a Spark data frame. All right. Then I can put in a list of data sets, which is a way here where we can put in the name and the file path and so on. And then at the bottom of the screen, I can start looping through that list of datasets by putting in for dataset in datasets. And I can start reading a data frame by calling my read CSV file function that I just created. And I put as the parameter in there the dataset file path that I'm iterating through at this moment. All right, so now I get the same thing. I'm reading the CSV file into a data frame, but I only need to create that CSV logic in order to read that CSV file only once. Okay. Same thing goes with the changing the date to the US date format, or changing our amount column by by putting in our data sets what name my amount column has in that file. So in the sales file, it's called revenue. In the marketing file, it's called cost, and so on. All right. So we can then put in a function that transforms our data frame, where I put in the data frame and the amount column as an example, as a parameter, and it will output a transformed data frame. So you can see that we start utilizing some of the reusable patterns that we have within Python in order to make our code base a little bit smaller. Now, mind you, in this example, because the example is so small, the total number of lines of code didn't really change. Maybe it was a little bit less than it used to be, but it didn't change that much. It will change, though, if you extrapolate this example, not from 3 tables, but to 300 tables, for example, right? That makes sense. It also makes it a lot easier to change your logic. Then the third stage, and that should be the one that you should be striving for, I think, is using custom modules. And what you now will be doing is writing these functions in a Python file, in a .py file. For example, the read CSV file, the transform data frame things that ask for input that gives you output, where we've used Python doc strings, the green text that you can see here, with a little description, with the parameter description, with the return description, in order to have our colleagues or code developers understand what's going on. And then we start importing the functions from this file, this module, and reusing them in our notebooks. And what we then can do is, let's assume we called our module data utils. We can now import that read CSV file and transform data frame, or we can import star to do an import of all the things in our module. And we can simply call the functions that are in our module. All right. So here you see that you put this code somewhere. For now, this is still unsure where we put it, but I will show you in a bit. And then your notebooks get super easy. And now you can have many different notebooks. You can have hundreds of notebooks, all importing that code, doing things, inputting and outputting data or values or whatever. And if you need to make a change, you make that change once, you republish your module, and all your notebooks will keep working. Right? And they will all be incorporated with that with the change that you just made. So here you have the pattern on how to actually make a truly repetitive module for your PySpark notebooks in Fabric. And then for the recording, putting these together so that you can, if you rewatch this, you can freeze the screen and look at how this works together. Are there any questions right now before we dive into the demo?
No questions right now.
No, nothing. All right, then
I look forward to the demo.
let's look at some live demo. I will jumping into Visual Studio Code. Can you guys see Visual Studio right now?
I can
It's a
see
black
it,
screen. It's
but
all no, it's a
hard
black
to
screen
read.
that's all very small, but you can at least see that screen, or do you still see the slides?
I see the screen, but I
Okay,
can't read.
you there's nothing on the screen yet, so but that's actually good. And we can also see Fabric here on the screen, right?
Perfectly well.
Amazing. All right. Let's start here at Fabric. I created a workspace for our demo today. And I prepared the environment and some notebooks and so on already in order to actually start working here. Let's at least start here by booting up a Spark session. That might take a while. So while that is going on, I will be talking about what we're going to do today. I have a lakehouse here called demo dry, and there is no files in here. I can double check that there's no files. No, there's no files and no tables in here, so that's cool. What we will be demoing today is having to update some of our tables with new data coming in. We want to do an upsert, meaning If it's a new record, we do an insert. If it's an existing record, we will do an update of that record. A very common pattern in data engineering. We will be doing that by inputting manual data frames so that we can actually see what kind of data we're loading. We're not connecting to APIs or any of that. Difficulties for the demo today. And then we will go through our, how do you say that? Our demo step by step so that we can see what is actually going on with the code that we just wrote. All right. Is the code readable or should I zoom in a little bit?
Zoom in a little bit.
All right.
Yes, perfect.
Like
Thank
that.
Yeah.
Now it's a bit more readable, probably.
Yes.
Okay, I have two demo notebooks here. This one is called our demo dry notebook because we have put the code in the notebook. And as you can see here, we import a library called delta.tables. We import everything from there because we will be interacting with delta tables in our lakehouse. But that's not the point of the session today. The point of the session today is that we have some reusable code here. I've created a function called upsert that expects a Spark session, a data frame, a table name, and a list of table keys. So that's one variable containing a list of keys. And the keys list could be one column name, it could be multiple column names, right? That are a composite key of a table. Now what this function is going to do, it is first checking if our delta table already exists by doing delta table.isDelta table. That returns a true or false. If inside my Spark session there is a table with this name, where I inject the table name parameter in the string here, using an F string in Python, that will give me a true or false whether that table already exists as a delta table. If it does, I need to perform an upsert, and I will be getting the information, the metadata of my delta table. I will be putting together the merge condition by looping through the keys in my table keys list and creating this SQL-like merge condition. This is actually one line that in SQL might take a lot of lines depending on how large the key of your table is. And then we will perform the merge by merging the delta table with our source data frame. And when there's a match, we will update. When there's not a match, we will do an insert. All right. So this is actually loading the data if the table already exists. If the table doesn't exist yet, it's very easy. We don't need to do any upsearch or checking if a row already exists. There's no table. So we could just create the table with our data frame by saying dataframe.write. And we will then save that data frame as a delta table. All right. You can imagine that this is a narrowed down pattern that we would be using quite often. But this should be quite easy to understand, I hope. If there's any questions, then please let me know. It's quite important if you want to follow the demo, but it's, I think, imperative that we can either create a table or load new data into a table using this pattern. All right. I should run the cell in order to actually initialize my upsert function here. And then we can do the initial load of our users table. So let's create a users table. We will define a table name, saying the table name is users. The table keys is a list, in this case, of one item. The item is a string with the value ID. And then we start creating our data frame. All right. This data frame, we saw that in the slides also. We now have a table of users with an user ID, username, user age. And initially, we will be loading in 3 records for Alice, Bob, and Charlie. Then we create the data frame using spark.createDataFrame. And then we will create our delta table by calling the upsert function. And now if you hover over this, you will see that this function is defined as upsert with a Spark session, a data frame, a table name, and so on. I did not properly declare the data types that my variables should have and the output of the function. As you can see that it will say any, it will expect anything. In practice, it is a good thing to declare how do you say that? The data types that we need here. But this thing is not a Python thing. It's not a Spark thing. It is a thing that we just created right here. Okay. What do we give this function? We will give it our Spark session. The Spark object within your Fabric notebook it gives the Spark session. The F is the name of the data frame that we put into the abstract function, and we have the table name and the table keys. So let's run this cell and see what happens. It should be quite quick. It's only loading 3 rows of data. There's some overhead involved in creating the delta table, I think. But we should be good in a few seconds. Of course, we're working with a demo effect here that things are taking longer than expected. But in 22 seconds, it was faster to actually write it down on a piece of paper. But in 22 seconds, our delta table has been created, or at least I think it has. I do see the green check mark, so I assume things have done what they should have done. We can check that. And just as an example, I put in a SQL query here to show you that you can create a data frame using spark.sql, write some SQL code, and then display that data frame. Now, mind you, we're reading from a table called users. There is no table called users here. So I hope that our process just created that table. Let's see what we have and if we actually have a table with data. We do. So we now have a table. We can probably refresh this and see that there is a users table in here with 3 columns. A column ID, name and age for Alice, Bob, and Charlie. All right. We can do a second load where we change some of the values for Alice and we add a new record. This was a proper incremental load. We only get new and change records. So when we start running this piece of code and then start looking at the data that we have, 7 seconds, it's a lot faster right now. That's good. Start looking at the data. I will expect Alice to be 29 years old and to have another record for John at 61 years old. And actually we do. So our the function that we're calling actually works. It works as we hoped it would by creating a delta table if it doesn't exist, by updating the delta table or updating and inserting into the delta table if it already exists. Now we can keep repeating and repeating and repeating, of course, but let's say run the cell and everything below so that it runs all at the same time. And then we can start scrolling through the notebook to see what is actually going on. You guys will probably believe me when looking at this data that it is doing what it says it does. We added 2 new lines to the users table. We created a new customers table. We did another load of the customer table with a composite key in this case. And you see that that works. We can refresh our tables list here and you see that next to the the users table, we also have a customers table right now. All right, so this is an example of running many incremental loads at the same one after another. Maybe we do this every day or every hour, it doesn't matter, but we don't need to execute that code in each cell or in each notebook every time that we execute the process. So we have this process somewhere, and then whatever the table is that we're loading, whatever the schema of the table is, whatever the keys of the table is, we can reuse the same code for all of those tables. All right. Again, a very easy example, a very dumbed down example, but it shows you how we can actually reuse a coding pattern that we will encounter quite often as data engineers. What I will do now is I will go to edit. I will clear my outputs just to clean it up. That is a good practice, I think. I will delete my delta tables. And again, delete that delta table here. I will stop my session and then we have to wait for a little bit. So I will show you now how we can actually set up this reusable piece of code that we've created inside our notebook, how we can use that actually as a standalone Python module that we then import into Microsoft Fabric. I will go back into my workspace. I will jump to the Visual Studio Code. There we are. And let's see if I can actually zoom in VS Code. I can. That's actually good. I prepared the Python project already before this meeting. It will take a bit too much time, I think, to do that live. So let's see what's going on here. If you created Python projects in Visual Studio Code before, it should be quite straightforward what we're seeing here. But let's start at the Explorer here on the left side. You will see that we have some folders. Upsert demo is our root folder. Inside, we have upsert for the module upsert that we're creating. And then we have init.py, we have setup.py, all kinds of files that we need in order to create a Python project. I will scroll through this so that you can look for yourself in the recording what we actually need in those files. So setup.py here is quite important one. Version.txt is a very easy one. You can just put a version number in there. It's not that difficult. Then we have requirements.txt, which shows us which libraries we actually need in order to run this piece of code. We need Delta tables, OS, and setup tools. The README is just a README file. It's not that important. And our init.py, this tells the setup.py file what code we actually do need to import into our module. So we say from upsert, that is this folder, we import everything, and then we create a list with all of the functions that we have in that submodule. In this case, we will only have one function in the module. And looking at the upsert folder, there we have an init.py and an upsert.py. Init.py again is a list of the codes that we have in our submodule here. And upsert.py is our actual code. All right. What we see here in upsert.py is that I just copy pasted the code from our Fabric notebook that we had right there. I copy and pasted it in here. Now, what I've shown you is that we enter the Spark session into our notebooks. We actually don't need to do that in a notebook. So when we're here in our notebook, this object here is not necessary to include, because when you're running your function or declaring your function within the same Spark session as that you're running the notebook in, it will understand that it should be running the code in that context. Once you start putting your code into an external module, it will no longer have the context of that single Spark session, because from many different Spark sessions you can call this code. So we should put in the Spark session or the Spark object into our functions. That's why I prepared this already. If you don't do that, you will run into errors. Anyway, simply copy and paste it, save the files, and that's it. There's nothing new here, so let's close this for now. What I will do in my terminal window here, if you cannot see that, go to View and then Enable Terminal, is I already prepared these. Run Python 3. And then dash version in order to confirm that we're actually running Python in our local machine at this moment. So on my laptop, I'm running Python 3.12 apparently, but this not only tells me the version number. I'm not that interested in 3.11 or .12, or I don't really care. I want to make sure that Python is actually running on my machine. Now we'll see that we're on my MacBook. We're in a folder called Upstart Demo, and now we can start running code in terminal in order to make a wheel file. And that wheel file is a distribution mechanism that we're going to use inside Microsoft Fabric. I already prepared that command as well. So with arrow up, I can cycle through previous commands, and I say Python 3 setup.py and then bdist_wheel. When I run this, it will actually start doing something. It will create files on the left-hand side in my Explorer. There we go. It will show me what it's done. It will also tell me, I think I should not be doing this. And I agree, we should be doing this in GitHub or in Azure DevOps. Please avoid running setup.py directly. But for today, for the demo, this is perfectly fine. Now, what happened here? I have created a distribution folder, a dist folder, containing a .whl file. The whl file is like a zipped folder containing my Python project. Nothing more, nothing less. It created this name out of the setup.py information with the name of the module, the version of the module, the Python version. So we can change 1.0 to 1.1 so that we can have multiple versions, etc. But I'd rather have Azure DevOps or GitHub do that. Anyway, for the demo today, we need this wheel file, and we need to publish the wheel file to Microsoft Fabric. So let's hop on over to Fabric. Let's look at our workspace and let's look at our environment. If you don't have an environment in your workspace, you go to new item, all items, you can start looking for environments right here. And then you create an environment. Whether you do it for analyze and train data or develop data, it doesn't matter. The environment is the same object. All right. And what does the environment do? Let's open it up. I will not be publishing the wheel file because it takes 10 or 15 minutes usually. That's too long for the session today. So we'll be looking at the pre-prepared environment here. So what does it do? It will show you all the built-in libraries that are available for Java, for Python, and for R inside of Microsoft Fabric. So if you're looking for things like, I don't know, pandas, it is probably already included by Microsoft into Fabric. You don't need to include pandas in your projects if you want to use this library. It is already there, and Microsoft makes sure that version 2.1.4 is available for you. All right. If you need a newer version of pandas, maybe 2.1.5 is released, and you actually need that in your stuff, you can publish it yourself and then overwrite the 2.1.4 that Microsoft has published for you. Okay. From the Python package index, you can also look for public libraries. The library that we created is not a public library. It is on my laptop only, right? You cannot download this from the Python package index. So we will be skipping this one for today. And will be instead looking at custom libraries. And you see here, upset demo 1.0, Py3, etc., etc. There is a wheel file in here. That is actually our packaged Python project that we just created. I mean, this is something I uploaded earlier, last year in November, actually. But this is the file that we just created. We can go here to upload. We can go here and delete something. So if we want to start updating to 1.1 or to 2.0, we can do that from here. And now, because our environment here is available, we can go into our workspace, into our demo workbook. Let's boot up the session, where we import upsert as up. You can give aliases as you want. I have told Fabric to run this notebook in my demo dry environment. We have the default environment from Fabric, and we have the demo dry environment. And we can have multiple environments in our workspace. In this case, we have only one. And within this environment, we can import upsert because that is actually available as a Python library. Now this is running. And as you can see, there is no mention of the code anywhere in this notebook. I am just calling up.upsert. Should not forget the up alias in this case. And it will actually just do everything we've just did in the previous example as well. But it will do so now through the Python module that we deployed instead of through code that is local to the notebook. I will not be going through all of the cells individually, but once the session has started, and because we're not using the default environments, but rather we're using a custom environment, this will take a little bit longer. It's a bit annoying, but once it's there, it's there. We will see that this will actually be loading all of the data in our lakehouse. Now, this is the same lakehouse we're looking at in here. We refresh, there's no tables in there because we removed the tables that we just created. The session has begun. The import is still busy. It takes quite a while. I'm not used to that. Okay, there we are. Let's say from here, the initial load, run the cell and everything below. Now it will actually start running the same cells that we had in the past example, but now through our module. And let's wait a few seconds for the first couple of results to pop up. There we are. That's actually quite fast. Less than 20 seconds. That's good. And boom, there we go. First table is now loaded. Looking at the refresh here, our users table is there. And we can now start keep scrolling, keep scrolling, keep scrolling. The notebook will just execute, and it will every time it will refer back to the Python module. It will do its thing. It will get back the data frame or get back the delta table, and it will continue. So let's refresh, and we will I have the customers table as well right now. So that concludes the live demo of this. I'm a bit over time, I think. But okay, let's skip this. We have already done that. Let's put it on the screen for a few seconds so you can pause the recording if you want. But we've already seen it. What we've done is we've created a Python project in Visual Studio Code. We then looked at how we can create the wheel file. We have learned how to import that wheel file into Microsoft Fabric. We can call them methods. I use methods here, not functions. We call those methods we just created. And in summary, we have learned today how we can reuse code. We can write code once and use it many times. We reduce the number of lines of code that we actually need to maintain. So maintenance will be easier. We will have less technical debt. That's always a good selling argument to your tech leaders, your CIOs, and so on. And it's easier to force your developers' guidelines. There's no handwriting anymore for any single developer working on your platform. So key takeaways is the drive principle enhances efficiency in software development. We will take this into data engineering as well by using custom Python modules. They're very powerful tools in Microsoft Fabric. And implementing an abstract framework like this makes it easier to develop and maintain. So my name is Bas Lans. I'm very happy to be talking to you guys today. A little bit of my background. I'll end with this instead of starting with this because it is actually the least important part of the session. But I'm the co-founder of Kimura Data Intelligence. We're a small 10-person Microsoft consultancy based in the Netherlands. Mainly working in the Netherlands and a few European countries, where we sell a standardized framework for Fabric and implement that. And on top of that framework, we build analytical products for several software developers, and we do some Fabric and Power BI consultancy. I'm married, we have a small dachshund, and we have a baby on the way. And next to that, I like to do sports. So I'm a purple belt in Brazilian Jiu-Jitsu. I lift weights, I run, I keep quite busy, as you can see. You can follow me on LinkedIn. You can also check out our new blog called thatfabricguy.com, where we'll be sharing knowledge like the session that we did today. We will be sharing all kinds of things on that blog from the technical Fabric perspective. And if you have questions, you can email me at bas.land@kimura.nl.
Great session. Thank you so much. And just
Thank
before
you so
you
much.
run off, we have a few
Sorry?
questions before you run
Yes,
off. So
please do.
again, Emmanuel has a great question, which is if someone create a package for Conda, will it be recommended to have a separate build using wheel?
Excellent question. I am not sure.
All right, fair
I'm not
enough.
sure. Not used Conda before in that regard.
I have another one from a lovely old lady, lovely lady I know, and she asked, is the wheel file content visible in DevOps specs? Is you're using Git integration in Fabric?
Okay, so is my screen still showing?
Yes.
Okay. I think if I understood the question correctly, there's actually two questions. One is if the environment and the wheel file contained in the environment, can we version control that? Yes, we can version control that using Git. I have not done that here, but yes, you can using, where is it again? Git integration here. We can put Azure DevOps or GitHub as a version control system on our workspaces. So yes, and also yes, the content of the wheel file can be made visible. So it is not visible from the get-go, just like if you can zip up files into a zip folder, the files themselves will not be visible necessarily, but you can unpack them and make them visible. The same thing goes for the wheel file. You can unpack the wheel file and see the Python files that are inside.
Right.
So in a version control system, you will have not your real file in version control, but you'd rather have your Python project, the one that I have in Visual Studio. You would put that into version control and then create the wheel file as an output of your version control.
All right. I think that was all the questions I have, and many people saying, great session, thank you. Thank you so much. They had a great time.
Amazing.
So overall, I'm very happy with the session, and it sounds like everybody else was too.
If you're not happy, also tell me. I'm here to learn as well. But thank you guys for attending.
Thank you. And until next time, which will be on the 18th of March, I believe. See
All right.
you. Bye.
See you. Cheers, guys. Bye.